Good morning, folks.
Good morning.
Good morning.
All right. Hopefully we're getting the core people in here in just a second. Like they were wrapping things up when I left. Good morning, Josh.
Good morning, Mark. Welcome back.
Thank you. You too.
Thanks.
All right. Let's see. Wonder if we're going to get the folks from the RGW team. They sometimes make it. I think Igor is coming too, so I may actually wait for him to come to talk about his PRs here. Or I suppose we could just talk about that after we go through all of them, so we can really talk about kind of all his numbers in his presentation and everything. Let's see here. Okay. All right, I'll get started here. All right. So we've got like 3 weeks of PRs here, although it ended up not being too bad. Although I may be missing some things in here possibly. Igor has a couple of new PRs that are both really exciting. One here is using deferred writes to avoid blob fragmentation when you have a small min-alloc size. I think he's going to talk about that later, so I'll just leave it at that. And then he also has one that's a hybrid allocator based on both AVL and bitmaps. So likewise, I'll leave him to talk about that. He's got some interesting performance numbers too that I think he was planning on showing today. Let's see. So also there is a PR here for improving SBDK performance. It looks like it's just kind of changing some of the code in the NVMe device to use kind of best practices. I guess we were doing some things that weren't great. So anyway, there's that. Would be really interested to see benchmarks on that. Closed PRs, we've got a bunch. This kind of small one from Radic, Kifu merged for mempool, switching it to Ceph Atomic. Another one for buffer list. I think that was just another small PR. Actually, a couple for buffer list from Radic. Another one for NVMe device, splitting the read I/O if the I/O size is large. I guess that kind of makes sense, maybe, given the small size for NVMe I/Os typically at the OS level, or the device level rather, I guess. Oh, my PR for increasing the default number of RGW bucket shards, that was closed, but it's just being incorporated as part of another PR by Casey. So that's good. And NUMA affinity improvements, I guess, for RGW here. Not a whole lot of other stuff. Inline mutable small object. Yeah, I don't know. I don't remember too much about any of these other ones, but looks like they were closed by a stale bot. Okay. Updated, more bufferless stuff. Igor's simplification of the O-node pin-unpin logic. So that looks like it's probably much better than what I was trying to do, but it is not passing tests right now. So just need to figure out why. but overall, looks really good. Our Rails GW admin allows zone. Oh, that's the one from Casey that incorporates my other PR. It just does a little bit more as well. Adam's big objection triumphant PR needs a rebase. I did see some updates after Patrick was seeing asserts in the MDS. So hopefully whatever he changed has resolved that. But needs a rebase and needs to be retested. Igor's PR for reducing memory footprint of data structures in BlueStore. That's been updated. I don't know what the current status is, if there's anything more that needs to happen with it or not. Igor, is that ready to be tested again?
Yeah, I just rebased it and it's ready for OK. But as far as I remember, we were discussing about postponing that initial Octopus release or something like that.
Okay. Sure, it makes sense. Okay. Cool. Okay, and then Paddock was also working on optimizing the shared LRU code. And it looks like Kifu did some initial review on that and then also has done further review. All right. So that's it for stuff that has gotten updates in the last 3 weeks. Our other Adam, I think, is still working on Chartered BlueStore. I don't think I've seen any updates on that recently. Josh, do you know if there's anything specific that we're waiting on for that?
I think that he had updated it with the latest approach. It might be a different PR now. I forget at this point. But I think it's ready for review.
Okay, cool. So maybe that's just stale then. Quite possible I missed the new one when I was doing my updates this morning, so I'll go back and look for it. All right. Not a whole lot of other stuff in here, I don't think. Yeah, nothing else really right now. So that's about it for the moment. All right, Igor, we have you now. I was wondering if you would like to talk about all the work you've been doing with both the deferred rights and your hybrid allocator.
Yeah. Would you like me to share my new benchmark numbers?
Yeah, it'd be great. Maybe as you're doing that or before doing that, just talk a little bit about what you did.
Okay, so the rationale about all this work is to bring 4K minilog size for spinners, which will reduce the space amplification that we might experience in recorded pools or when keeping tons of small files and things like that. Well, our initial attempt showed that we might experience some negative performance impact on when downsizing allocation size, and hence I was trying to fix it somehow. And one of the major reasons for performance drop is the additional fragmentation which our default allocator, which is bitmap 1, might produce in 4K scenario. And finally, I decided to. So I tried some tricks with bitmap allocator, but finally I decided to AVL one, which based on AVL3s, and we have it in master, but it's not default at the moment. The major difference between these two allocators is that AVL allocator is pretty good in finding continuous blocks, since it maintains a sort of tree, and hence it can search efficiently, while bitmap needs a sort of sequential search to find such blocks. But on the other hand, AVL allocator might consume pretty high amount of memory when we have significant space fragmentation. I measured the size of the single range of the structure to maintain single range within this AVL3, and it takes 80 bytes. And hence, if we have plenty of 4K ranges or maybe a bit longer ranges, RAM usage might grow pretty high. And actually, we experienced the same issue with stupid allocator before. So in production, we've got multiple complaints about excessive memory usage in production after a while. While bitmap allocator has constant RAM usage and pretty good in this case. So the idea, I decided to try, which I called hybrid allocator, which is based on existing AVL1 and uses it for fast search for long ranges, as well as use it basically until we some memory threshold. And then it falls back to bitmap one to keep everything that doesn't fit in our memory constraint. So that's it. In this hybrid allocator, when we fell back to bitmap one, we still use AVL3 or AVL allocator implementation as a sort of caching, again for searching these continuous blocks. And well, so that's a sort of workaround to bring both fast searches and limited memory constraint to all our allocation schemes. That's the rationale for hybrid allocator. And one more scenario that showed some performance drop is when we downsize mean allocation size, is long reads, like OMAC reads from objects which were initially filled with again long writes, but then partially written by some small blocks like 4K. And in case of 64K minalog size, these small overrides result in deferred writing procedures, which keeps existing long blobs untouched, so they still benefit from the continuity, and hence further reads benefit from that. But when we migrate to 4K minalog size, such overrides broke the continuity, and subsequent reads are suffering from that. In fact, we have a sort of trade-off here, at least for 4K min-log size. So on one hand, we have when we do regular writes, we have faster writes, but subsequent reads are slow due to resulting fragmentation. On the other hand, if we apply deferred writing, performance drops, but subsequent reads are fast. So the results that I've got, I tried hybrid allocator with deferred writes, and this is an attempt to preserve current performance numbers we have for 64K min-log size. So if we decide to have better writes, then we should avoid these deferred writes, but we will suffer from slower reads.
Igor,
but
we can't.
yeah.
I don't know if you're trying to share your screen or not, but
No, not yet. Not
oh,
yet.
okay.
Let me. Do I need some permission for that?
I don't think so.
Really quick question. Is this just reusing the existing preferred option?
Yes.
So that basically if you defer a write, then it will overwrite existing blobs instead of allocating new ones. That's really the change behavior.
Yeah.
Okay.
Absolutely.
Yeah, that makes sense. If once you're deferring, it's always going to be better to use an existing blob than to write a new one, basically.
Well, from writing performance, it's not better.
It's
at least
the same.
Yeah. Well, it's the
because
same.
You're still doing two writes.
Okay, let me share first, and then I'll try to.
I guess it might be more seeks because you have to do a bunch of them.
Can you see my screen? Okay, so just the row number 12 shows 4K writes, overwrites over prefilled store. And we can compare, for example, columns B and C. And there is a pretty significant difference in writing speed for 4K min-log size. I suppose there are two things which result in this improvement. First one, lack of deferred writing, and the second one is probably when doing multiple writes, they into a single. Multiple writes become continuous, and hence inner perform that fast enough. But when we try to read objects of read in this way, the picture is completely different. So reads are slower for 4K min-log sizes and in 64K. So objects which were written using deferred procedure, reading from them is faster. Let me try to find it's confirming that. Actually the row 18, this is the first long readings, and you can pretty great numbers for reads for 64K min-log size, and major drop for all the cases which avoid deferred writing. And the last column, which is F, it's a sort of an attempt to recover to original numbers, but I haven't still reached original numbers. But anyway, they are much better than without deferred.
No panacea, basically.
Igor, it looks to me like both your 8 to 128K random write and your large write, like 4 megabyte write numbers, significantly improved with both the AVL and the hybrid allocator. Was that
Yeah,
correct?
yeah, looks like that.
Do we have any understanding of why?
Probably finding bigger extents, so it's fewer writes.
Yeah, so when we use 64K blobs and bitmap allocator, we tend to use 64 extents. But when we use AVL allocator, we tend to use extents similar to the rights that user issues, and probably they are long in average, and hence reading is faster. Both reading and writing.
Are the extents in the bitmap allocator, like if you're writing out a 4 megabyte file and you're using like smaller extents, do those extents tend to be sequential, or is it that they're just kind of like random? Is that why we're seeing it?
It depends on the state of the store. So on the initial run, when it's empty, or we just form some writes sequentially, it tends to return continuous blocks. But if we reset the allocator, restart to SD, it will start search from the beginning, and hence tend to return fragmented.
Okay.
In fact, I recall that I found that sometimes AVL suffer from the same issue, but not sure I can explain that right now. So if you look at lines 34 and 35, which is 4K writes, you can see pretty significant difference in writing performance for AVL 4K case. And as far as I remember, that was exactly because restart of the allocator results in finding more fragmented extents, and hence the drop, or something like that. Maybe I'm not very good in explaining that right now, but well, again, it's sometimes we might experience pretty interesting numbers when we start pretty interesting difference when restarting allocators, both bitmap and AVL1. So when we run initially, they tend to return continuous blocks. But after restart, if some releases happened before, they start to return more fragmented space.
What's the difference between line 34 and line 35?
Just another run for your process. But generally, that's a restart of the allocator. So it starts from the beginning. Well, for bitmap, it starts from the beginning of the space. For AVL, a bit different, but I'd say it starts to return. Well, imagine the first run of the AVL allocator, which needs to allocate two 4K chunks. At the initial run, it will return from offset 0 and from offset 4K. So the resulting extent, or these two extents, are continuous, and subsequent writes will most probably benefit from this continuity. But when you perform some releases to this allocator due to different writes, it tends to have a list of short extents which are scattered over the store space or disk space. And again, when you try to allocate two extents independently, I mean, that's not a single write, but two different writes. So they do two calls to AVL allocator, and the resulting resulting extents are not contiguous. They might locate at different disk locations because previous releases happened at random locations. And actually, this difference between two runs of the same allocator on pretty the same store most probably explained by this logic.
So sorry, just so I understand, in that on line 34, it's like the first run, and then line 35, it's like a subsequent run after something's changed?
Yes. It's
Okay, and
just so we performed write for for pretty short time. We just written 200 megabyte, then restart the whole process, restart the allocator, and it resets some it has internally and starts searching from the beginning, and performance drops. Well, again, it's absolutely true for bitmap allocator, but as far as I remember, it's pretty the same for AVL. But well, let me double check that offline. I'll provide that explanation in written form. Mark, can you hear me?
Yeah. Sorry. Yep. I was just looking at more of your numbers here. I mean, some of these are really impressive. I mean, the random write non 4K, like the bigger ones, 8K to 128K. I mean, sometimes it's a 3 to 4 times performance improvement on the first run. Second run is still 50%. Like I'm looking at 37 and 38, or sorry, 36 and 37.
57. Yeah.
Yep.
Those are
But
test ranges.
mm, just one remark here. Generally, all these benchmarks are pretty artificial. So in production, it might be less visible, both drops and improvements. Because there are plenty of factors like fragmentation, write block sizes, and things like that. The previous releases, how they happen to the store. So. But generally, I like the results which are provided by VL, by hybrid or VL allocator plus deferred writing. Except the case when we want fast FOK writes. But that's an avoidable trade-off, I'm afraid.
And why are the 4 megabyte random reads half as fast, or in the deferred case, like line 18?
I don't have explanation for now. So I know why these DD and E columns are that bad, but still not sure why I haven't reached the original performance for deferred writes. I'll check that. I don't know at the moment.
Overall, it looks really, really exciting. Good job, Igor.
Mm-hmm.
Thank you.
All right. So I guess the other thing I was going to mention this week is while I was on PTO, I kind of got to work on a project that I've wanted to do for a while, but has been kind of backburnered, which is to run the IO 500 benchmark on Cephas. We're on the list that they have right now. I've got it in the Etherpad here, but I'll link it in. So this is the 10 node challenge from the Supercomputing 2019, and as you can see on it, Ceph is there. We are represented, but we're kind of down near the bottom. I think Suze was able to get a score of around 12.5. That puts us at place 18 of the top 25 here. So I started working on it using our new Officinalis nodes, and so far I've gotten us up somewhere around place 13 or 14. Pretty variable results. I see us typically getting anywhere from about 20 up to around 34 now is kind of the highest I've gotten it most recently. I did see it, I think, once higher than that, and we did beat the 13th place result, but I have not yet been able to repeat it. So we're close. We're kind of hovering pretty close to 13th place. But that's kind of where we're at right now. What I'm seeing is a lot of kind of hard to understand behavior. I guess is the best way I'd put it. I'm seeing slow sequential reads with both the RBD and the CephFS kernel clients. So I don't know why that is yet. I need to dig into that more. That's one issue that's really hurting us because it's in this test it's about 17 gigabytes per second, and we should be able to do far better than that with this hardware. With highly parallel reads with librd, we actually can hit about 60 to 70. So lots and lots of room for improvement on that front. The other big thing that I'm seeing is I'm having a really difficult time trying to consistently get balanced inodes across MDSs and then also balanced requests across MDSs. Probably due to that, but also sometimes I've even seen kind of weird behavior that doesn't seem to match the distribution of inodes. So even with perfect pinning, I'm seeing kind of weird inode distribution sometimes. By perfect, I mean we've got clients set up with to write into specific directories with an equal number of files, and each of those directories is pinned to a specific MDS such that all MDSs have an equivalent number of clients only talking to them for the directories that they're working in. So theoretically, we should have an equal number of files represented on every single MDS, and then doing stats and other things across all of them across the whole cluster. It's oftentimes when I do a small set of tests, it works the way it's supposed to. But in certain cases, I haven't really narrowed down exactly all of them. I'll see only one MDS getting a huge number of inodes, and then occasionally some other ones popping up here and there. It's almost like it's reverting to the balancer behavior, but it's not good balancer behavior. It's really unbalanced. So I don't get it. I do need to probably update my kernel client so I can make sure that all of the pinning happened properly, because right now I can't actually check them. Getting the X adder doesn't work, so there's that too. Let's see. We tested the ephemeral pinning PR. Thank you to Patrick. He found a bug in it that was causing even kind of more unusual behavior. So that's at least figured out. So we're not using that at the moment, but potentially once that gets fixed, we can try that again as well. And I also did try the Fuse client, and some of the results are maybe slightly hilarious. Everything runs quite a bit slower, maybe 10 times slower. But the one case that was even worse was using or the MD test hard delete case. And I need to actually verify exactly what that is doing. But I was seeing about 21 ups per second across all 100 MDSs that I have set up. And LS was hanging, everything was very, very slow. So I'm assuming it's just a bug, but I don't know what it is yet there. So kind of the last thing here I'll say is I don't feel like I have a very good understanding of what actually is going on under the hood regarding the balancer, and also even with pinning. I've looked at the pinning code, so I more or less know how it works, but I don't understand why I'm seeing some of the things I'm seeing. So I think that's really kind of what I need to do next, is just try to get a better understanding of this. And Patrick pointed at me at some good scripts that he's got for kind of cataloging and analyzing both the subtrees that you can look at through the Ceph commands, and then also the looking through the perf data and correlating that. So that's on my list of things to try to get working and looking at as well. So that's basically it right now. We've got numbers that are non-qualifying, but we do have numbers that are looking much better than what's up on the IO 500 list right now. I think we can do much, much better. We've got the performance in the OSDs to do it. We just need to kind of figure out what's going on here, or at least I need to figure out if it's something I haven't set right, or if it's things that we need to change in the code. So that's it. Patrick, anything you wanted to add based on what we've seen so far?
Yeah, I mean, the only thing is it would be, we definitely want to try to graph some of the behaviors we're seeing that would probably figure out what's going on in terms of anomalous behavior. The ephemeral opening had some weird bugs, and that kind of invalidates all the results. I'd expect the normal export pins to work pretty well in terms of distribution. I mean, I've exercised those pretty heavily in Linode, and I'd expect to get linear metadata performance scaling in the Intel cluster. I don't see a reason why not. I don't know if you mentioned, but one interesting thing that Mark's doing is he's got 80 MDS ranks in his cluster, which is not something I've done before. So it's conceivable he's uncovering some new issues in Ceph by scaling that large. So I'm excited to see what some of the graphs produce. At the very least, we're going to try to get some SQLite databases of all the performance stats so that we can try to see if there's any strange behavior going on. Graphing it might be difficult just because of the number of MDSs I think it would require. Using the graph scripts that I've currently written, we might have to either look at only a subset or write new graphs, but the latter usually takes a while to do. And with so many MDSs, we'll have to be a bit creative with how to represent that on paper.
And Patrick, I can scale that down really easily too. Like I could, in about 5 minutes, I could scale that down to building a new cluster that would, have like 20 or, whatever we want to test, if that makes it easier.
Well, 80 is certainly an interesting number of MDSs. I mean, I don't have any reason to believe it wouldn't work. So if you can make it scale that much, that would be, I'd love to see what kind of results we get. But if it's just falling over, then in the interest of actually getting results that are useful, we might want to scale down and then debug the large number of MDSs out of band.
Patrick, one other thing that I did look at was lock contention in the MDS. When I was doing these tests, I was sometimes seeing like really high CPU usage. Well, not high, it's like 200 per daemon. So like 2 cores being used, maybe up to 3. But when actually looking at like a wall clock profile, it seems like we're waiting on locks a lot. And I don't know the MDS code that well, so I don't know what exactly we're waiting on. But the per MDS throughput never really got. That's not entirely true, but it typically never got higher than around 10,000 ops per second. Does that kind of match with what you'd expect, or is that unusual?
Yeah, that's pretty normal.
Okay.
10,000 ops per second. In terms of lock contention, there's just this one big MDS lock that you might be seeing in your analysis. We have broken out some tasks in MDS, namely the journaling, the purge queue. So if you're doing an unlinked workload, you might see that thread get pretty hot. And then a few other small upkeep tasks, but it should not be that significant. So most of the work is going to be done in the messengers threads and the MDS lock, or whatever thread's using the MDS lock.
Yep, that was what I was seeing, is that the messenger threads were all quite busy, and they were also spending a fair amount of time waiting on whatever, probably that big lock then that you were mentioning. And then there was in the two different wall clock profiles I looked at, each one had different time spent in a couple of other threads. I can go back and look at them again, but that was what I was typically seeing.
Yeah. But more generally, we haven't done a lot of analysis of any call stacks and profiling for the MDS. So, you know, you're kind of venturing into new territory. Jung has done some of that, but generally he's just been fixing small hotspot PCs here and there. But I don't think we've done any kind of systemic analysis of the MDS.
Okay. Cool. Well, so yeah, that's where I'm at right now. Hopefully we can. I'll try to get those. Try to get your Ceph gather script working, and then maybe we'll have more data for you to look at.
Yep, that sounds good.
Cool. All right. Well, that's all I've got. Anyone have anything else this week that they'd like to bring up or talk about? All right. Well, thanks for coming, everyone, and we'll see you next week.
Thanks all. Bye.
Yeah, thanks, bye.
Have a good day, guys. Bye.